You are walking down a quiet street. Nothing is wrong. Then a shape moves at the edge of your vision. Your body reacts before your mind even knows what it saw. Your heart jumps, your shoulders pull in, you flinch. A half second later, you realize it was just a plastic bag caught in the wind, but the real answer to why you jumped is far stranger than the bag itself. Your brain reacted to a threat before you consciously saw one. That is not a glitch. That is a system working exactly as it was built to work, hundreds of thousands of years before plastic bags, before streets, before you. Think about that for a moment. You flinched at nothing, but your ancestors did not have the luxury of waiting to be sure. To understand why, you have to go back to the architecture of your own skull. Deep inside your brain sits a small, almond-shaped cluster of neurons called the amygdala. It sits low, close to the brainstem, wired directly into your senses. Long before signals reach the parts of your brain responsible for conscious thought, they pass through here first. The neuroscientist Joseph Ledoux spent decades mapping this exact pathway. He found that visual information travels along two separate routes at once. One route is slow and careful. It runs through the visual cortex, the part of your brain that builds a clear, detailed picture of what you are looking at. The other route is fast and crude. It skips the detail entirely and rushes straight to the amygdala. Ledoux called this second path the low road. The low road does not care what the shape actually is. It only cares whether the shape looks like danger, and it makes that judgment in a fraction of the time it takes you to blink. This is why you can jump at a coiled garden hose before you register that it is not a snake. Your amygdala already voted. Your slower, smarter cortex is still catching up. Why would evolution build a system that reacts before it even confirms what it is reacting to? Because for most of human history, being wrong in the direction of caution cost almost nothing. Flinching at a bag costs you a second of embarrassment. Failing to flinch at an actual predator could cost you your life. The psychologist Arne Ullman studied this trade-off directly. Working with colleague Susan Minica, he ran experiments testing how quickly people detect threatening images hidden among neutral ones. Over and over, people spotted snakes and spiders faster than they spotted flowers or mushrooms, even when the images flashed for only a fraction of a second. Ullman and Minica proposed that humans carry what they called a fear module, a piece of mental machinery shaped by millions of years of encounters with things that could kill us. Here is the part that surprises most people. This module does not need to be taught. Ullman and Minica's research suggested that fear of snake-like shapes shows up in infants and even in lab-raised monkeys who had never seen a real snake before. The wiring came preloaded. You did not learn to fear the dark. You inherited it. Picture your ancestors 40,000 years ago. No streetlights. No walls thick enough to keep everything out. When the sun went down, the world did not go quiet. It went dangerous. Every rustle in the grass carried a real, non-zero chance of teeth. The humans who survived long enough to pass on their genes were not the calmest ones. They were the ones who flinched first and asked questions later. That means every single person alive today is descended from an unbroken line of people who were, quite literally, built to jump at shadows. Now, here is the twist. This ancient alarm system was never built for accuracy. It was built for speed. And a system built purely for speed is going to make a lot of mistakes. The psychologist Daniel Kahneman described something similar in his work on fast and slow thinking. He divided the mind into two systems. System 1 is fast, automatic, and emotional. It jumps to conclusions with almost no effort. System 2 is slow, deliberate, and logical, but it takes real mental energy to switch on. Kahneman's research showed that System 1 runs the show far more often than we like to admit, and it is rarely interested in being right. It is interested in being fast. Your amygdala is System 1's favorite tool. It does not wait for permission. It does not check its work. It reacts, and then it hands the situation off to the rest of your brain to clean up afterward. So what does this actually look like in your daily life, thousands of years after the last predator stopped stalking your ancestors through tall grass? It looks like your stomach dropping when your phone buzzes with an unknown number. It looks like your chest tightening before you have even opened an email from your boss. It looks like the spike of alarm when a car horn sounds behind you, even on a street where you are perfectly safe. None of these things are predators. Your amygdala does not know the difference. This is the strange part. The system that once scanned the grasslands for movement is the exact same system now scanning your inbox, your group chat, your notifications. The environment changed completely. The wiring did not update. That mismatch has a name among researchers who study evolution and modern behavior. They call it evolutionary mismatch, the idea that a trait shaped by one environment can become miscalibrated in a very different one. Fear is one of the clearest examples. The mechanism that once kept your ancestors alive now spends its time firing at spam texts and unread messages. Does that mean the fear is fake? Not exactly. The feeling is completely real. What has changed is the target. There is something almost humbling in that. Every time you feel your pulse spike over something small, a late reply, a strange noise upstairs, a stranger walking too close behind you, you are not overreacting by accident. You are running software that is tens of thousands of years old, doing exactly what it evolved to do, in a world it was never designed for. Knowing this will not switch off the amygdala. You cannot think your way out of a system built to move faster than thought, but there is something useful in simply recognizing the pattern. The jolt you feel is not a verdict on the situation. It is a proposal, fired off in milliseconds by a part of your brain that specializes in worst-case guesses. The slower, wiser part of you gets the final say, if you give it the extra half second to catch up. So the next time your body reacts before your mind has caught up, before you have even consciously registered what startled you, remember what is actually happening underneath. A message is traveling down the low road, bypassing careful thought, chasing a shadow of danger that stopped following your species long ago. You did not imagine the fear. You inherited it, intact from every ancestor who flinched first and lived long enough to pass that instinct on to you. The plastic bag was never the point. The reflex was. And somewhere inside you, it is still working exactly as it was built to, waiting for the next shape to move at the edge of your vision.